Through its Cottrell Scholar Program, Research Corporation for Science Advancement champions America's very best early career teacher scholars in chemistry, physics, and astronomy. The initial Cottrell Scholar Award provides significant funds for basic research. But RCSA also offers Cottrell scholars several more levels of competitive funding. Post-tenure Cottrell scholars may compete for the prestigious Frontiers in Research Excellence and Discovery, or FRED Award, named in honor of RCSA founder Frederick Cottrell. The FRED Award supports early-stage, potentially transformative research. In 2016, Carlos Meriles, a physicist at the City College of New York, became the first Cottrell scholar to receive the FRED Award, based on his work with nitrogen defects in diamond.
Ultimately, you can imagine using these defects as nodes for processing information in what now people are referring to as the quantum computer, which is the next frontier in information processing.
Meriles and his colleagues have already demonstrated the feasibility of manipulating and storing information in point defects within diamond crystals at room temperature under ambient conditions. They are manifesting one aspect of the immense possibilities of the subatomic realm outlined by theorist Richard Feynman in his 1959 speech, Plenty of Room at the Bottom.
Imagine just a crystal the size of 1 by 1 by 1 millimeter. And there you can actually go to store the information of an entire library.
In 2014, the Nobel Prize in Chemistry went to 3 researchers whose work in super-resolved fluorescence microscopy enables us to see beyond the diffraction limits of light, allowing scientists to visualize the pathways of individual molecules inside living cells.
What we are now trying to do is to take advantage of this. The technique, the way it is right now, was mostly conceived for imaging, to see things beyond diffraction. But it's limited in their ability to control what happens beyond diffraction. You can see things, but then in seeing these things, you modify what's around the target, the object that you want to see. And that for us is sort of deleterious because imagine you're storing information around the target. Now you're destroying the information that you've already stored when you try to read it, if you are not careful. So the whole idea of the FRED project is somehow to go around that problem.
Meriles and his research collaborator, CCNY physicist Vinod Menon, are attempting to find reliable methods using laser light to alter the electron count or charge in point defects on diamond, thereby creating the ones and zeros that store information in the digital realm. And they're also attempting to incorporate a read-write memory process based on the phenomenon of electron spin.
Carlos's group strength is spin. They study a lot about charges and spin and things like that. My group's expertise is optics and light and photons. And this is a very unique marriage that you can bring together, especially with our labs being right next to each other, to combine spins with photons.
Before the information held by charged atoms is destroyed, the team is attempting to transfer it into nuclear spin. Meriles likens nuclear spin to the needle of a compass pointing up or down.
If you now have to interact with a volume that is defined by diffraction, and you know that your interaction with that volume is going to alter the charge states, these extra electrons, in this whole volume, and therefore destroy the information that you are trying to store, then the idea is that before you do that, you actually pass on that information to this other degree of freedom, to the compass. So now the compass is going to be pointing up or down, correlated to having or not having this extra electron. So part of the research that is going to accompany this Fred Award has to do with understanding those details, figuring out exactly what the conditions are so that we can go back and forth in the best possible way.
Tony Liss is Dean of Science at CCNY. He oversees many of the activities going on inside the school's billion-dollar materials science complex. The facility is designed to promote interdisciplinary collaborative research.
Big discoveries are never the kinds of things you can predict. But we hope that Carlos is going to make a real splash with his work on nitrogen vacancies, and that can have applications in all sorts of devices and maybe someday in quantum computing.
So the work that Carlos is doing and the work that I'm doing in collaboration with Carlos could lead to building blocks that work towards these quantum technologies. It could be as signal processors that do quantum manipulation. It could be for receiving an input signal or an output signal, all in the quantum regime.
I think that this Fred Award came at the exact right time for me in my career and in my research in particular, especially in a sort of tight funding environment like the present environment. Going out there and competing at this early stage with these ideas would have been really very, very challenging. So this Fred Award for me is very special.
For more than a century, Research Corporation for Science Advancement has funded the innovative work of early career scientists like Carlos Meriles. Today, through the Cottrell Scholar Program and its Frontiers in Research Excellence and Discovery Award, RCSA is nurturing America's next generation of scientists and teachers. Research Corporation and its community of scientists are working to build a brighter future.